Hi, this photograph shows a picture of the cliffs at Bridport in Dorset on the south coast of England. The rocks here are sandstones. We call them the Bridport Sands. And it's part of a really interesting deposit that we find across a good part of southern England. It's thought that these beds were laid down in a sandbar in a river back in the Jurassic. And what I want to do in this lesson is try and use the ammonite fossils as zone fossils within this to tell us something about how this bed was laid down. Okay. At the end of the last lesson, we were looking at this outcrop of rock and how the ammonites within this showed us the time zones in which these beds were deposited. And we noticed that the beds don't actually coincide with the time zones that the fossils tell us. So, for example, if we look at the bed X, Y, and Z, that one bed of shale is deposited in 4 different time zones. Perhaps this bed is being actually laid down at a bit of an angle. The conditions that are needed to deposit that shale actually move over time. This type of bed is called a diachronous bed. Diachronous literally means through time. And it's perhaps a little more complicated than we're used to when we think about layers of rock being all deposited at the same time. Let me try and show what this means by looking at this real example. The Bridport Sands are part of a bed of sandstone that we can find across southern England. Here are 4 locations where we can find this. The Dorset coast that we've already seen, Yeovil and Somerset, Bath, and also then in the Cotswolds. These sandstones were laid down in the Jurassic. Because of this, we've got some really good zone fossils in a type of cephalopod we call an ammonite. Now we can divide the Jurassic up really in a very detailed way using different ammonites. And those are shown on the left in those different fossil zones. What I'd like you to do is I'd like you to have a go at question 5 on page 8 of your theme booklet. See if you can use that information to work out what's going on with these places. You may also want to use an atlas or Google Maps to find where these places actually are. So press pause now and see what you can come up with. Okay, let's have a look at a few answers. So this is the piece of data we're looking at. If we look first of all at the zones where we'll find the Cotswold Sands. Zones 4 and 5 are the fossils that we find within the Cotswold Sands. Remember, of course, by the law of superposition, the oldest ones are going to be at the bottom, the youngest ones are going to be at the top. The Bridport Sands, though, we see a different collection of fossils. Here we see ammonites from zones 11, 12, 13 and 14. So if we're putting these in order, the oldest ones are the Cotswold Sands, then the Midford Sands, then the Yeovil Sands, and finally the Bridport Sands. But remember, this is all the same environment. This is the same sandstone bed, just being deposited at different times in different places. Now we can actually use this to work out how this was being deposited. If we look at a map here of southwest England and southern Wales, if we look at where these places are, Bridport there on the south coast, going all the way up to the Cotswolds in the north. Now remember we said, or we've just worked out, that the oldest outcrop of these sands are in the Cotswolds, the youngest one in Bridport. So this sandbar must have been moving to the south over geological time. Perhaps as rivers from the north were depositing this sand into the shallow sea, those rivers were expanding out to the south, depositing the same bed further south through time. So, as we look at sunset over Bridport Bay, these fossils, and using zone fossils in particular, can tell us a huge amount about the age of beds we're looking at, but also they start to piece together bits of the story. We can interpret a lot more about the geology if we know the time periods at which this happens. What we need to do next time is look at which types of fossils are useful at different periods, because they're not all good for the whole of geological time. I'll see you then.